Now that you understand how to prepare and visualize data, let's explore data modeling and the data load editor in Qlik. Before diving deeper into the data load editor, it's important to understand the levels of abstraction in data modeling. Data modeling is the process of creating a diagram that represents your data system. It outlines how data entities are structured, their attributes, and the relationships between them. Data modeling helps organize and simplify complex data, making it easier to understand, manage, and query while ensuring consistency and data integrity. Data models are fundamental to shaping your data architecture, designing databases, and modernizing legacy systems. Through data modeling, you define how data is organized, stored, accessed, and displayed. This clarity supports business intelligence and analytics by making it easier to locate, trust, and use relevant data. Data modeling defines how data is structured and related. Levels of abstraction bring order to this process. At the conceptual level, we focus on the big picture, a high-level, business-focused view of data structures. We define the main entities, their attributes, and the relationships between them. This level is independent of any technology and is primarily used to communicate with business stakeholders. Moving to the logical level, we add more detail. Tables, columns, data types, and relationships are defined. The logical model provides a detailed logical view of data structure linking conceptual and physical models, ensuring consistency and normalization while remaining independent of any specific database system. Finally, at the physical level, the model is implemented in the database. This includes tables, columns, indexes, constraints, and storage details. The physical model is optimized for performance and maps the logical design to actual database objects. There are different data modeling techniques depending on the use case. In analytics, dimensional models play a key role. Dimensional modeling is a schema design approach that organizes data into fact tables for numeric measures and dimension tables for descriptive contexts such as who, what, when, and where. You use structures like star schema or snowflake schemas, which is ideal for online analytical processing or OLAP to support fast, intuitive analysis, reporting, and business intelligence, with a focus on query performance rather than transaction processing. It is optimized for select queries, enabling extremely fast data retrieval for reports. OLAP systems enable you to quickly explore and analyze data across multiple dimensions, such as time, region, and product. Here's a sample diagram for a dimensional modeling using a star schema. Fact tables store quantitative metrics, while dimension tables store descriptive attributes. Understanding these concepts helps you build efficient data models that are optimized for analytics and ready to load into Qlik. A clean, well-structured data model ensures your visualizations are accurate and efficient. How does dimensional modeling work? Here are the high-level steps. First, identify the business process. Focus on core activities such as sales, orders, or calls. Second, define the data granularity. Determine the lowest level of detail for the fact table example, 1 row per line item in an order. Then, identify dimensions. Determine the descriptive context such as date, customer, product. Next, identify facts. Determine the numerical measurements such as sales, quantity, etc. Lastly, build the schema, structure into fact and dimension tables, linking via primary/foreign keys. In Qlik, tables are connected through key fields, forming associations. You can review and refine these relationships in the Data Model Viewer, where tables, fields, and links are displayed visually. For more advanced control, we use the Data Load Editor. The Data Load Editor lets you connect, transform, and load data directly using scripts. It offers greater flexibility than the Data Manager. Let's open the Data Load Editor and go through the UI so that we can navigate smoothly once we start with our hands on. This is used to search and replace text in the script. This is used to comment or uncomment snippets of a query. To improve the readability of our queries, We use this to add indentation and this to remove indentation. Another technique to improve the readability of the code is to use this to add script sections. The sections are executed from top to bottom. This is used to undo changes, while this is used to undo the latest undo. The Data Sources button shows you all available data sources. To debug our query, we use this. This helps you test your load script step by step. Lastly, once your query is fully tested, you may load your data by clicking this. The following slides are intended for hands-on work. Still, before the hands-on, we will learn some important concepts, such as using load and select statements, resident loads, preceding load, concatenation, and preventing concatenation. In Qlik sense, data loading starts with two core statements, load and select. Both create internal tables inside the Qlik engine. Use the load statement when working with files such as Excel, CSV, or QVD. Use the select statement to pull data directly from a database. A key difference matters during transformation. Field renaming only happens in a load statement. Select pulls fields from the source as is. For this reason, a preceding load often sits on top of a select to reshape data during ingestion. When data is loaded into Qlik sense, the engine treats all tables the same. The source does not matter. Load, select, or a mix of both produce equal internal tables. Field order does not influence processing or associations. Only field names matter. Qlik sense uses matching field names to link tables. Field names are case sensitive. Sales ID with capital I and D and sales ID that are all in lower caps create separate associations. Renaming fields in the load script is often required to produce the intended data model. Next, let's look at transforming data using resident loads. A resident load pulls data from a table already stored in memory. This approach supports advanced transformations. Examples include date formatting, numeric handling, and Qlik-specific functions not available in database queries. Resident loads help simplify logic and reduce database dependency. Another transformation method is the preceding load. A preceding load chains multiple load statements together. The top load draws data from the statement directly below. No, from, or resident keyword appears in the top layer. Execution starts from the bottom and moves upward. Each layer applies filters or transformations in turn. This structure keeps scripts clean and readable. Now let's discuss concatenation. Concatenation combines multiple tables by stacking their rows into a single table. Columns align by matching field names. No values change. The final table contains the total number of rows from all source tables. Qlik sense automatically concatenates tables when their field names and counts are identical. Sometimes this behavior causes issues. To prevent automatic merging, use the noConcatenate prefix. This forces Qlik sense to create a separate table, even when the structure matches an existing one. Understanding these behaviors helps you control data structure, associations, and performance in Qlik sense. Now, please go to the deck, download the required files, and follow the instructions for the hands-on. In this chapter, you learned data modeling concepts and levels of abstraction. You reviewed dimensional modeling and the basics of the star schema. You examined associations using the data model viewer. You navigated the data load editor interface. You learned core scripting concepts such as load versus select, resident loads, preceding loads, and concatenation. Thank you, and see you in the next chapter.